Has anybody looked at the problem set? Anybody else? One, kind of, sort of, got one head. Anybody else? In the back? Nobody? I'm warning you on this one. This is confusing and complicated, much more so than any of the prior sections. And there are a lot of assumptions. First, he's assuming you're familiar with trig identities or how to derive anything that had to do with trigonometric form. He's also assuming you're fairly familiar with how to do convolution and tricks with convolution. And I'll get to that in a second. Now, I did 351, I think, but I want to start there quickly and go through this to make sure everybody's on top of it. And before I even do that, one thing I want to do is say this, that in general, remember before, back in the day when you had signals and systems, you remember if you had two functions, f of t, and it was convolved with g of t, in this domain, it was equivalent, if this is the time domain, and this is the frequency domain, it was the same thing as f of omega times g of omega here. Now, typically what you did, if you had two functions, you could convolve them in time. Usually the convolution was more involved, took more time, it was more confusing. But if you could simply take the Fourier transform of that, and the Fourier transform of that, then you could multiply the Fourier transforms together and get the result that is another Fourier transform, and by taking the inverse of that, you could get the actual value of the convolution of the two things. Now, you could also do it with Laplace transforms. And with Laplace transforms, you can do it this with Fourier, you all agree? And you could do it with Laplace as well. So with Laplace, this would be the estimating would be f of s and g of s, right? And the difference is with Laplace, then we did partial fraction expansion. It usually became trivial. Do y'all remember that class? Not trivial, but I mean, you understood the transform pairs that were essential, and you could break it down. Do y'all remember this class? Now, I like this and this. I don't like this. But you have to be able to form a problem in terms of a convolution before you can do the Fourier transform business. Y'all follow me? So I'm going to start with 3-5.1. Start there, do it again. And before I say anything more, here, remember how that we had a variable z. These are random variables, and with some x plus y. These are all random variables, right? If that was the case, we could say the probability of z being less than some small z here was the same thing as the probability of x plus y being less than some small z. Right? Then what you could do is say if you wanted to do it with y, you could say y itself, or better yet, x was equal to z minus y here. I'm just redefining that. And you could say, well, this is a double integral. And if f of x comma y can be broken up into f of x, f of y, remember, that assumes they're statistically independent. This is a prerequisite for doing what I'm saying here. If they're not statistically independent, what I'm showing you won't work. Then you have to go through the whole 9 yards and do this, basically do this integration with the limits. So here, you're going to get, basically you get f of, these are from minus infinity to infinity on the first one. And here, if we're going to do the x integration, it goes to z minus y, and this would be f of x dx, and this would be f of y dy. Now, I'm putting it down there the way the book did. I haven't done the derivative. Do y'all follow me on this, guys? When you take a derivative of this, now you get the density function for z. This part will remain the same. And then you get f of y. And then with the derivative, you just simply take the upper limit, replace f of x's argument with it, and eliminate the integration. So this becomes f of x of y minus z. And it's going to be dy. And this is the definition of convolution of the two functions. It's really going to be fy of z convolved with fx of z. I'm just putting this down. Y'all follow me on this, class? So that is, and z is a dummy variable. I mean, z could be t, could be anything. But basically, you're getting rid of the y is what you're integrating over. It's like before you integrated over lambda or tau, right? Okay, remember that. So that's convolution. Now, with 3-5.1, I want to go through, start there and just whip through these.
Okay, is this the exercise or the problems?
Problems.
Problems.
We did the exercises, I believe, right?
Yes, we did the
I want to
exercise.
start here with the problem, because these are more complicated. In my opinion, they're, especially some of the latter ones, are much more complicated. Go ahead.
Okay, so you have a random variable x as a probability density function of f of x equals 2x for x greater than 0, less than 1, and 0 elsewhere. And an independent random variable y is uniformly distributed between -1 and 1.
Okay, so f of y is equal to 1 over, one half from y equal greater than -1, less than 1, right?
Yes.
And it's 0 else, right? Now it's randomly distributed. The mere you see, uniformly distributed. It has the same value, f of y, over that range. What that tells you is the area under the curve of f of y integrated over the range that exists has to be 1. We know the width is 2, the height has to be 1/2, so the product of the two is 1. That's the only thing I'm saying. Everybody with me on that? Okay, now he says something else. This is the trick.
And he wants to find the probability density function of the random variable z equals x plus 2y.
Now there's several ways to do this. I'm going to do it the way he did it, and I'm going to say what he's always thinking is this. If I have a random variable z that's x plus y, and I have the density functions of x and y, I can just use convolution of f of x and f of y to get f of z. That's his goal, all right? Here, I don't have just x plus y, I have x plus 2y. Follow me? So he creates a new function, y prime. And he says y prime is equal to 2y, right? Now, y prime has a density function, right? We need to find f of y prime. Well, the extent of that, if y goes from -1 to 1, y prime goes from -2 to 2. You all follow me, class? So I'll just draw it up here so everybody has a mental idea of this. So when I look at my f of my y prime here versus y prime, this goes from -2 to 2. The density function has to be uniform, therefore it's 1/4 in height. I'm just showing you this. This is exactly what he does. You can do it a couple other ways, but this is the easiest in my opinion. Y'all follow me? So he's using, I mean, it really pays to be a little clever, think it through, how to make it easy. You can make it hard. Boy, you can make these problems hard. But that's what it comes down to. Now, that said, therefore my variable z that I'm actually going to do the convolution of the two things is going to be equal to x plus y prime, and I'm going to convolve f of x with f of y prime. Is everybody with me on the reasoning? I'll do that over here. By the way, his definition of the characteristic function is not consistent with our definition of the Fourier transform, but it doesn't matter because it's just the transform pairs we care about. And you'll understand what I'm saying in a second. So let's go and just deal with this one. So we have over here, what we need is the convolution f of z is going to be the convolution of f of x of z convolved with f, it's convolved with f of y prime of z. You all follow me? I'm putting that argument there so you remember. We're convolving two functions, it'll be an argument of z. Now, the way I do this, because I like to do simply a method of flipping and shifting and moving things through each other. It's easier for me to see this. Right? So I know for convolution in general, it's always going to be an integral from -infinity to infinity of the first one, f of x, and it'll be, you can call it lambda, tau, whatever. And then it's going to be f of y, and it would be of z minus lambda, d lambda. It doesn't matter if it's lambda or whatever. You're going to integrate that variable out. So the symbol there is not important. And this will be my f of z. So now, obviously, Go ahead.
For that, are we still dealing with f of y prime, or did it change
Or
back
y
up?
prime, sorry, y prime. Absolutely, it has to be, because it won't work if it doesn't. Remember, my z value is going to be equal to x plus y prime. Thank you, though. You follow me, class? The way I always tell people to do this, since we have to draw these two functions over the different ranges that they exist and see where they overlap, because this is a product, so the two have to overlap at the points of z and z minus lambda, right? And then you multiply them together to get the value, correct, class? So I'm going to say that f of x probably has the most going on. I leave that alone. I just plot that versus, in my case, lambda. Y'all with me? So here it's going to be f of x of lambda. And this is versus lambda, and it's simply this, right? And that's 1. It goes to, that's just from
0 to 1.
0 to 1, yeah. So it goes from just 0 to 1. So this is 1. And here's 2 and so forth. Now down here, the way they usually say is you first flip the image of the one you're going to move through or shift through. So mine goes from -2 to 2, right? When we flip it, it looks exactly the same when I take my f of y prime with minus lambda. It's going to look the same. Now I'm going to just try to emphasize this fact. It's going to look the same. The height is 1/4. It starts at -2, goes to 2. As this would be for z equals 0, right? But actually the upper limit here, if you look at this, the upper limit here would be 2 plus z, correct? Over here. I flipped it, so this becomes, if you take a look at this when we flip and shift, this is going to be 2 plus z, it should z plus 2, and this is going to be z minus 2, correct? I just want to make sure everybody's got that in their head. Correct, class? Now, you can see when z is -2, it just starts to come in. And I'm going to try to make sure I emphasize that point. So if I take a look at what this will look like when z is -2, it looks like, or between -2 and -1, it looks like this. This is still going to be z plus 2. And down here, this is going to be z minus 2, but now we're talking about, I'm going to erase this right here. When I take a look at this, now I need regime, so here I'm going to say for z greater than -2, less than -1, that's this. Now I have to multiply this, which has a height of 1/4, by this, and this right here is going to be 2 lambda is the equation for that line. Do you agree with me? So I multiply these together, and then I have to integrate them, right? So I multiply 1/4. If you look at this, what I'm really after is this area of the overlap. Right here, I have 2 lambda times 1/4, and I have to integrate it from 0 to z plus 2. Do you all agree? So for here, I'm going to get my f of z here is going to be an integral from 0 to z plus 2 of simply 2 lambda divided by 4, or lambda over 2 d lambda. And that's going to be simply lambda squared over 2, or lambda squared over 4, and it becomes simply z plus 2 squared over 4. Now you can expand that out, but that would be f of z in that range. Do you all agree with that? Now, let this thing go a little. I won't do this for everyone, but for this one I want to make sure everybody's got it, because that moving window, please send me a message that I send everybody the JavaScript on this one. I didn't send this to everybody. Just send me an email. Please send the class the JavaScript for convolution. It's really a nice thing, because you can literally write out the mathematical function and do it, or you can sketch it, which is, thank you. All right, now I'm going to move this, and now I'm going to go from z here is going to be greater than -1. Now think about that. So I'm going to try to show you this. Now we have this. We're going to have some, this is still z plus 2 here. And back here, this is going to be z minus 2. Now think about this. It's going to have complete overlap, right? If z is equal to -1, this is still 1, that's complete overlap. If z is equal to 0, it's 2. The bottom one down here, if you take a look at that, when z is 0, this is still minus 2. Then when z is equal to 1, this is minus 1. And when z is equal to, z equals 2, this becomes 0. Follow me on this? I'm sorry, I'm saying this kind of awkward. But you're with me? In other words, this window, as it moves through, for 2 time intervals, it's going to be, this is going to be completely buried in it. That's my point. So it's going to be from minus 1 to what? To 1, isn't it? No, let's see. To 2, right? Do you agree with that?
Yes.
Sorry about that. All right, and at 2 it starts. So here, then my f of z is going to be a constant, and that's just going to be the integral. It would be from 0 to 1 of lambda over 2 d lambda. And that's lambda squared over 4, or just 1/4. So it's going to be a constant from there to there. Do you all agree with that? Now, one thing about convolution, whenever you have stuff like this, you can almost predict the outcome. You know that the width, if they're both finite, I mean, if one of them is finite, if both of them are finite, the width is just the sum of the two, would be the width of the convolve function. Here we have one that exists as an existence from 0 to 1. The other, it has a span of 4, so the total will have a span of 5. Do you all follow me on that, guys? Right? You know what I'm talking about, the horizontal width f of z? Because we're literally taking the two functions, multiplying them, and then integrating through. So now the next part is from z greater than 2 but less than 3, if you take a look at this. Isn't that right? Now what happens there? I'm going to move it through. So when z is 3, this becomes 1, right? And that means we'd just be moving out of the overlapped area because that's the trailing edge. So between, show you this. This is still z plus 2, this is z minus 2, but here we're going to go from 2 to 3. Now when z is equal to 2, it's still completely overlapped, but then it starts coming through here, and then the area of overlap looks like this. Let me move it through even further. And this becomes the area of overlap right there. So I have to multiply 1/4 times 2 lambda. I get lambda over 2 and integrate from here to 1. So here, my f of z is really going to be the integral from z minus 2 to 1 of lambda over 2 d lambda. So it's lambda squared over 4, evaluated from z minus 2 to 1. And that's simply going to be 1/4 times 1 minus the quantity z minus 2 squared. And again, you can go ahead and multiply that out and get what you want, but that's the answer. Do you all follow me, class, on this one? How many looked at this one? I'm just curious. 1.5. 1, 2, 3. Okay. I'm hoping more people did, but I understand if you didn't. I want to make it absolutely clear. Remember, this is sort of just an exercise in convolution once you understand the method. You have to get functions that have the form x plus y equals z. Follow me? Now, if you add x minus y equals z, I'm just going to give you a little preview. Then you would convolve fx of z and fy of minus z. But that comes later. That's in one of the problems later, though. We'll get to it. So that would be the answer. I think he asked you to draw it, right? Versus z. And if you look at this, for the first one from z minus 2 to minus 1, it's basically this, and that's sort of a quadratic thing. It's going up like this. Then it hits a constant value of 1/4, comes down here, and then at 2, right here, it starts coming down, and it'll do this when it comes down. It looks like a shark fin, sort of, if you look at that. The front, you know, that's what they used to call a shark fin. All right, everybody with me on that, class? Is there a part, does he ask for anything else?
He has to find the probability that z is greater than 0, but less than or equal to 1.
Okay, if this is greater than 0, just take a look at this, guys. Just tap your attention for 1 second. He wants the probability, this is f of z, right? That's a quarter high. And he wants the probability of z greater than 0, less than 1. Isn't that right? Now, what does that tell you? It's the area from here to here, right? That's width of 1, height of 1/4, that's 1/4. Is that the right answer? With me?
Yeah, it is.
Just by looking. Okay, what's the next part?
No, that's it for 3 Tech 5.1.
Well, I got a question for you. So, what's the probability of z being greater than 2? It's this area, right? Isn't it, class? Correct? Well, how do you get that area? You take this and you would integrate it from 2 to 3, correct? Now you can do some tricks here. You can, if you take a careful look at that, you could probably make a variable change here to make the integration a lot simpler, but it's just the integral of that. Does everybody follow me? For z goes from 2 to 3, right? What's the probability of z being less than 0? Once you have f of z, it should be straightforward. It's the area under here plus this, right? This area is just going to be 1/4, right? So you got to just integrate that and add to it. Follow me on this, class? And if I asked you the expected value, it gets a little trickier. Then you're going to have to integrate whatever z is, if you expected value with respect to z, not x or y, but z, then you would have to multiply this function by z and do the integration. Do y'all follow me on that? That'd be a little more difficult, but it's the method is the thing to keep in your mind. You can work through the details of it. Y'all agree with that? All right, 5-2. Let me erase this. I think this problem sets the stage. It really kind of identifies the fact we're going to convolve things. We've got to find a way to craft the problem in terms of x plus y, if at all possible. It has to be, they have to be independent random variables, or else you can't do this. If they're not, then you have to do the whole 9 yards. You have to write the equation for f of z in terms of the probability of z being less than, in terms of the integrations, and do the integrations. And then do the differentiation. But I might add, that can be probably a little much, unless you have some method. I mean, if you have mathematics, it can do all that symbolically, and it's amazing tool. Okay, go ahead.
All right, so 3 Tech 5.2. A commuter attempts to catch the 8 a.m. train every morning.
Go ahead.
Although his arrival time at the station is a random variable that is uniformly distributed between 7:55 and 8:05 a.m.
All right, so this has got a height of 1/10, and I'm just going to call this f of x. So f of a, arrival time of t, right? And then over here he has the train's departure time, right?
Yes.
I'll call f of d of t, and that goes from 8 to 8:10, right?
Yes.
It's got a height of 1/10. Go ahead.
And then he wants you to find the probability density function of the time interval between the commuter's arrival at the station and the train's departure time.
All right, now, for just to craft this in a way to make a little more sense to everybody, or to more or less state it with, I'm going to call this f of arrival of x, and call this variable x, but I'm going to do one other thing. Y'all see they're centered at 8 o'clock, right? We're going to remove 8 o'clock. We're going to subtract off 8 from everything. And we're going to say this is going to be -5. Now, this is my method. I think it is his method too, but I forgot exactly. And that goes from 5 to 5. Now, at the end of the day, what we'll do is account for the 0 movement. We'll add 8 o'clock to everything. You with me, class? Over here, we're going to say this goes from 0 to 10. All right? It's got a height of 1/10. That's 1/10. Here's what we got. That's f of x. I'm going to call this versus x. And this is going to be, call it, I'm going to make it y. Y of y. Remember, these variables don't matter. We're going to integrate those out. Y'all with me on this, class? At the end of the day, when we convolve this, it's going to be a function of whatever he's going to state. But what he says is what he wants to know is to state something in terms of the difference between the time of arrival and time of departure. So this, by the way, is departure. I'll call this f of x. And just put this as arrival. And this is departure. Time. So then he says, what I want is a variable z, and this is a little different. And he's going to say z is equal to x minus y. Y'all follow me? It's no longer x plus y. That's the difference between the two, right? Time of arrival minus time of departure, and he wants that. Now, I want to make sure everybody's good with this, right? Before, what we had was this. We had f of z was equal to, and we convolved the two, but technically what we had was an integral from minus infinity to infinity of the first function, or f of y, and then the second function was f of x, and here it was equal to z minus y, and this is going to be dy. Do y'all remember that? But now our upper limit, and I could rewrite the integral, is not z minus y. What is it going to be? This is x. It would be x is equal to z plus y, isn't it? Do y'all see this, class? So I'm going to craft it like so. You'll see this. There's a couple of different ways to do this. So this is going to be z plus y right here, because remember that was the x integration. We went from minus infinity to the upper limit, and for x that would be x is equal to z plus y. Everybody follow me on this? Did anybody look at this problem, by the way? Anybody at all? One per, you did, Zach? Did you notice? Now they do it with negative convolution. They have the argument for convolution negative, but this is going to be the same thing. Y'all with me? Now, when we look at this, very similar to convolution, right? But instead of flipping it, you don't have to flip the function. That's the beautiful part. So find the two functions, find one that's got the most going on. When I look at this, just take a look. It doesn't matter, really. So I'm going to make, and I'm going to do something here that I really try to make sure you understand. So I'm going to make this a lambda. That way, I think you might be able to see it better. Maybe it's just me, but I want to make sure you see it. That's a dummy variable. All the graphing is going to be with respect to lambda. We look at the area of overlap and do the integration. Now he picked two functions, where if you look at them, they're constant values. There's no tricky integrations. He's done it on purpose to just get us our feet wet with this so we understand the method before things get really out of control, and they will. All right, now over here, which one do you want to flip? Or I'm sorry, which one do you want to shift? I'm going to do it this way. You can do it any way you want. I'm going to leave this one alone. All right, I'm going to leave that and just plot it versus lambda. So that's the first function up here. So for that function, it goes from -5 to 5, right? And it's just got a height right here of 1/10. That's my first function. I call it f of x of lambda. Now the second function, right here, take a look at this. What I'm going to say is now, if I graph it, I'm just going to graph the function. This is going to be my f of x of z plus lambda. This is versus lambda. If z was 0, this would be f of x of lambda, right? And this would be just this, would be, let me make it this way so you see. This would be 10, this would be 0, and the height would be 1/10. It's just this function. I'm sorry. Yeah, I'm sorry. F of y of lambda, my bad. F of y of lambda. You all follow me on this? Now, technically right here, this is going to be lambda plus z. So the upper limit is going to be actually 10 plus z, and the lower limit is just going to be equal to z right here. You all follow me? Now just look at this for 1 second. Remember, there's no flipping in this one. We leave it alone because the method doesn't call for any flipping and shifting through. Do you all follow me? So when we take a look at this, well, it overlaps here, but where does it begin to overlap? When z is equal to minus 15, isn't that right? At minus 15, it'll look like this, and I want to draw this out for you. I don't know a better way to do this, but exposure to this. So we're going to go down here, and we're going to say this is going to be z plus 10 here, and this is going to be just z down here. The height is 1/10, and this is the area of overlap, and I'm going to do it right here. So for z greater than minus 15, now from minus 15, how long until it's going to go for a full 10 seconds, right, to minus 5? Do you all follow me on that? Yeah.
In his solution, he starts at -5 and goes to 15, so he like flips it.
Then what he does is he leaves that one alone and he flips this one.
Maybe.
But I mean, you all follow me on this? You got to leave one alone and you got to move the other. Well, if you move the one that was there, you got to start at minus 15. Doesn't he have z equals minus 15 somewhere?
He goes from -15 to +15.
Yeah, but we're going to start at minus 15.
He starts at -5 though.
How does he get an answer with minus 15 in it?
He goes from -5 to +15. He goes the other way. I don't know if I've been saying that right.
Wait. When z is minus 15, that's where this starts, right?
He says it starts at -5 though.
I think he's maybe using the other.
It doesn't matter though. We have to get the same answer for this, no matter which one we flip and shift.
Yeah.
I'm not sure.
Let's see just for a second. I think this works. So for z greater than, yeah, it should be right. But let's just see what happens here, because the limits may straighten this thing out when we do the integration. For z greater than minus 15, less than minus 5, right? What happens? I get my f of z here. It's going to be equal to, and yes, the integration starts at minus 5. That's right. Starts at minus 5, right? And it goes to z plus 10. And the value here is going to be 1/10 times 1/10, or 1 over 100, and this is d lambda. Take a look at that for a moment. We start here, right? And it starts at the lower, it's going to start at minus 5, and it's going to go until we hit z plus 10. Do you agree with this, class? So what happens? You're right about that, but you got to do the integration to see this. So for this one, we're going to get 1 over 100 here. Then we get simply lambda, and this is going to be z plus 10, right? And then it's going to be lambda minus 5. Let's see, is that right? So then we're going to get z here over 100. And we got 10 minus 5 is 5. 5 over 100 is going to be 1 over 20. And this is going to be for z greater than minus 15, less than minus 5. Does he have this right here?
He has the first part. He doesn't have his limits again. They're from -5 to 5 instead of -15 to -5. He has it shifted over by 10.
Shouldn't it be minus 5?
Pardon?
Should it be minus 5? So +1?
You're right. You're absolutely right. My bad. And that would be that's 15. Yeah, that's 15 over 100. Let me just see. I'm going to do this thing. I know the correct way to do it doesn't matter which one you flip and shift. Give me 1 second. I'm going to use, I think I see, I know how he did it, but what I want to do is this. And it shouldn't matter which one you flip and shift ever. That'll have no bearing on that. I'm not sure his answer is right. I think we all agree that will render the right answer, no matter what. Now, for us, that's going to do the right answer. I wanted to leave this one alone because if I shift this, we can try it that way. It shouldn't matter which one that one doesn't have to be shifted. Okay, I think I see what he's doing. So for this one, if I leave that alone, right here, this is still going to be lambda here. Height is 1/10. And then for that one, right here, this upper limit would be, this is going to be this one here is f of y of y. Of lambda. And this is going to be f of z of, f of x of lambda plus c. Here, it's 5 plus c. This is 5 minus c. This should work no matter which one we move, though. So for this one to start at 0, it would be at -5. Ooh, wait a second. No, it should work.
Would it be different because it's x minus y? So if you did the y one shifted, you'd have to like flip it versus if you did the
Well,
x one,
if you look at this argument, this is f of y of lambda. This is my f of y of lambda, right? Down here, this argument is z plus lambda, right? The plus. So there's no flipping. So this is it, right? Now,
Yeah.
the whole idea is for this, I know what the limit. The problem is when you look at this, here's the problem. Z is equal to x minus y, right? So I calculated x was equal to z plus y. If you look at y on the other side is equal to x minus z. Do you follow me? Now, if you do it that way, and that's the problem. If you do it this way, this would be the limit for the y integration. You would have an x minus z. It would change the actual structure right here. I'm so sorry about this. This one I'm going to leave. That one I'm going to leave alone, and I'm going to have to go ahead and shift this one. And that's my f of x. Here's what I'm really trying to tell you right here, and I didn't say it explicitly the way. When you look at this, here's the one we're using as a substitution. But remember, when you take a look at probability of z less than small z, probability of x, in this case minus y, less than z. Now it's that double integral. And if you take a look, if you do the x integration first, you get y plus z here. F of x dx from minus infinity. Here it's minus infinity to infinity of f of y dy, right? Now, here, when you take the derivative of this with respect to z, you're going to evaluate this function at y plus z. You follow me on that, guys? If you would do it the other way, and you would do the y integration, or I should say, yeah, for the y integration it would be z plus x. If you do that over here, and you have this double integral, and then you go from minus infinity, and down here it's going to be x minus z for f of y dy, and this is f of x dx. Now the upper limit there, when you take the derivative, would be z minus x. Do you follow me? It would change the structure of that, so you can't just take one and shift it. You got to do it the way it actually says, and this will be the one you have to shift. So when z is equal to -5 is when the beginning area overlaps. Do y'all follow me on that, guys? How many see this right here? If you take z, just make the argument here, z is equal to -5. This would be 0, right? That's when this leading edge starts moving through. That's my point. You with me? So, trying to move along with this one, if you take a look at this, that means for z greater than -5, and then, let's see, -5 here, it starts, this would be 0, this would be +5, so from here to here, now I get f of z equal to, and it's just going to be a linear ramp, so it's going to be a value of, this would be z over 100, and it's going to be plus, and then, let's see, that's going to be, when the area overlaps there, you're gonna have 10. I'll just write it out actually. Do it. So you're gonna have f of z here equal to, well, that's gonna be 1/100 here. Then it's an integral from 0 to the upper limit would be 5 plus z. And it's just simply d lambda here. So that means f of z is 1/100. And then it would be, this is just the lambda. And that would be times 5 plus z. So it should be z over 100 plus 1/20 for z minus 5 less than 5. Is that the correct answer there?
Yes.
I'm
Yeah.
sorry, I was messing that up.
Yeah, that's right.
I forgot. If whenever you get this, is x minus y, it depends which one goes first. And you have to, when you go ahead and do the shifting and stuff like this, you gotta literally set this thing up, set the definition of the probability up, take the derivative, and see what it comes out there. It's not as simple as just x plus y where it's defining convolution. You with me for that one? Then what happens for, so this is for minus 5 to 5. What happens when z is greater than 5? Now at that point, now this end starts coming through, right? With me on that? And so it looks like this. Actually, now here's the area of overlap. So therefore for z greater than 5, less than, what would it be, 15, f of z here of z would be equal to 1/100. Now it's an integral. The lower limit is z minus 5. The upper limit is going to be 10. And it's just d lambda. And that is going to be 1/100. And it's 10 minus the quantity z minus 5. And so what is that? That's going to be 10 plus 5 is 15 minus z over 100. Does he have that for 5 to 15?
15 yeah, it is.
And that's going to look like this. And I'll put it here. I want to put, because I want to do this problem entirely. I'm sorry I messed that part up. I should have recognized that. So if this is z, f of z here, of z, it starts at minus 5, 5, 10, 15. And it does, let's see, the peak is going to be when
It's a 5.
it's plus 5, so it's right here, and it's going to do this. It's going to ramp up and then ramp down like this. It's going to be a symmetric triangle. And the peak value at 5, it's 1/10 right there. So this is going to be 1/10 at 5. And now what does he ask for, sir?
He wants the probability that you will catch the train.
Okay, so here's what he's going to say, because I did this problem last night. We define the time of arrival minus time of departure. Well, anytime that's positive, you catch the train. Do you follow me? If you arrive before the train departs, it means x is greater than y, or that's greater than 0. Does that make sense to everybody? Basically, you're going to catch the train. So what's the probability that you catch the train? It's what? It's all this area, isn't it, class? Probability that z is greater than or equal to 0. So it would be 1 minus this, wouldn't it, class? If that's 1/10, this is going to be 1/20th in height. So what I can say is the probability of z greater than 0 or equal to 0 is really going to be 1 minus this area there, which is going to be what? Well, the width is 5, so it's going to be equal to 5. The height is 1/20th, but this is a triangle, so it's times 1/2. So what is that? That's going to be 1 minus 1/8, 7/8. I think that's the right answer.
Yeah, that's right.
Do y'all follow me on this? You could integrate from here up, but why bother if you can just take 1 minus that? Because the integral from there to there has to be 1 by definition. All right, what's the next part?
If the commuter gets delayed 3 minutes by a traffic jam, find the probability that the train will still be at the station.
All right, now, what he's really saying is, find the probability that this is 3 or greater. Does that make sense to everybody? Because if it's delayed by 3 minutes, it means the train itself, arrival time of the train, is going to be 3 minutes later. It means, but if this is still 3 or greater, it's fine, right? So where's 3? It's unfortunately right here, right? So what can we do? Now just think about it. They want the probability that we still catch the train, right? Just think about this. Well, this entire probability, all the area under that curve is 1. If you take 1 minus this area, we should be okay. Does that make sense? So the probability of z greater than 3, and that just tells you that now you got a 3-minute cushion. If it's delayed by 3 minutes, big deal, you're still okay. So what happens? Well, that's going to be 1 minus, what's this area here? Just think about it. Well, if you look at this, right, the slope of this, if you think about the rise is 1/10 from here to here, the run is equal to, the rise goes from 0 to 1/10 over a run of 5, right? So rise 1/10 divided by 10 is 1/100th, correct? So if you think about this right here, it has a span of 8, right? The actual slope is going to be 1/100th, so this height would be what? 8 over 100 here, right? This area, therefore, will be 8 times 100 times 8 divided by 2. Or we can say it's 1 minus, and it's going to be 8 times 8 over 100, and then divide that by 2. Now, what is that going to be? That's 1 minus, and this is 64 over 100, right? Well, what is that? That's 46 over, is that right? So it's going to be, is that 46 over 100, whatever that is? Does he have that?
He got 0.68, but
Well, I think it's because you got to divide by 2 still.
Oh, yeah.
So you got
Wait, no, hold it. This is 8 over 100 is the height, times 8, right?
64.
Divided by 2, correct?
Should be 32 over 100.
Yeah, it should be 64.
You're right.
Yeah.
32. This would be 200. Oh, yeah. It would be, this would be 200, 64 over 200. And that's, what is that? 0.
You got 0.68.
That's right. I believe that's right. Y'all with me?
It's 146 over 200.
This is 64 over 200, and this is here. So it should be 1 minus 64 over 200, or 32 over 100. 1 minus 32 over 100, and that's going to be 0.68. That's, oh shoot. All right, next one. Boy, I didn't mean to mess that up. In a way, I'm probably better off doing it that way, messing it up, because you won't make that mistake. But it's kind of it gets a little tricky sometimes, because you have to go back to the fundamental definitions. Does he show that with a negative convolution stack or not?
Show what with the negative?
Does he have two functions involved, and one of them has a negative argument in this one or not?
Oh, in 353? I don't have a problem.
Was that 3?
No, that was 3 tech 5.
No, I mean just in the solutions.
Oh, in 352?
Yes.
You have a negative?
If he doesn't, don't worry about it.
I don't think so.
Okay, go ahead.
Alright.
3-5.3.
So you have a sinusoidal signal as
this
the
is-
form.
All right, here we go. We have x of t is equal to cosine. This is a real good problem. I think it's 100t plus some phase angle. I'm just going to put psi there. And then we have y of t is equal to cosine of 100t plus some phi. Now, if you look in the solutions, you're going to get a little lost. And he's saying these two are random variables. Theta and psi are random variables. And they're uniformly distributed. So basically, what he's from 0 to 2 pi. So from 0 to 2 pi, both of them have a height of 1 over 2 pi. And this is going to be my f of theta. And it is also my f of psi. They're both the same, if you look at that. Now he says this is a tricky one. It took me a minute to take a look at how to do this next part. Now he's going to say he creates a new variable, z of t, and that's going to be equal to a times cosine of 100t plus a new variable. Now I'm going to use this. I'm going to use gamma here. Only reason whatever that's called. Anyway, the only reason I'm using this symbol is because I can't, if I put phi down here, it's going to look too much like that. So I can do it this way too. I can use the true definition, gamma that way. Okay. Now, he wants you to find the value of A that will make this true. It's x of t plus y of t. Y'all follow me? So he's going to say, if you add these two together, find the value of A that'll make that true. We can find the angle too. Y'all with me on this? Now, you can get lost in this one if you're looking for trig identities. Here's the way I'm going to do it. He does not show you enough in the book so you can figure out what happened. I don't think. I mean, the solutions. I got to stop for a second to show you something. This is the beginning of the difficult problems, and they get a lot more difficult. So anytime you have something where you have cosine of any function at all, of theta, that's really the real part of e to the j theta. What I mean by that is, if you look at a complex plane, if this is j and this is the real plane, when I take a look at e to the j theta, here's theta, this would have a value of 1, and the projection of that on the real axis would be the definition of cosine of theta. Y'all with me? Now, anytime you have something like this, where you have 100t plus theta, 100t plus psi, and you add those two up in a complex plane, remember, it would be the projection on the complex plane. Y'all with me on this? I want to show you. Here's what I'm actually going to do to make life easy. This 100t does nothing but rotates the hands of the clock for all of them. That's all it does in the complex plane. Doesn't change the actual dimensionality of what I'm about to show you. So if you take a look at this, and I take a look at the first one, I'm going to do is just cosine. What I'm going to do is say this. What I'm going to look at is this. I'm going to look at z of t is simply going to be equal to cosine, or it's going to be a cosine, a times cosine of gamma is equal to cosine of theta plus cosine of psi. All right, I'm going to show you something, but we're going to take a look at this, and we're going to take it in the complex plane. What I'm really going to say is this right here is going to be a times the real part of e to the j there is equal to simply the real part of e to the j theta plus the real part of e to the j psi. And you're going to see something here. So, can you all follow me out? I want to do this in the complex plane. Remember, there's a coefficient a that's strict real in front of that one. So first I do this one. So here's the origin, this is the imaginary axis, this is the real axis, right here. And this has a value just e to the j theta, complex plane, has a value of 1, this is theta. Now for the next one, I go from into this one, and I'm going to say this one has a value of 1. Here is going to be the other variable, it's a psi. Finally, I'm going tip to tail on this. I know that this would be the value of A, and this would be the angle gamma. Can you all follow me on this? I'm trying to draw it up in a way that's meaningful. Now we do the obvious. This is how he gets what he gets. I'm going to say, well, if I take the projection of this one and this one, it has to be equal to the projection of this one down here. Do you all agree with that? So I'm going to get A, right, here, and it's going to be A cosine of that is equal to, and then I get cosine of theta plus cosine of phi. And then I take the projections in the vertical direction, and I get A times sine of gamma is equal to cosine of theta, or I'm sorry, sine of theta, my bad. Sine of theta plus cosine of sine, or sine of sine. I'm sensitive to the clock right now, but I'm trying to show you. Do you all agree with this, first of all? Right? Projection down here, A cosines of all of them. Projection here, A sines of them, right? Now, I go ahead and I square this, and I square this and add it together. So I get A squared plus sine squared and cosine squared is 1 is equal to, now I square those. So I get cosine of theta plus cosine of psi squared, right? That's that one, plus, you can almost see what's happening here, sine squared of theta, or sorry, sine of theta plus sine of psi squared. Y'all with me? Now, take a careful look at this. You all see how I'm going to have a cosine squared of theta, and I'm going to have a cosine squared of psi. Do you all see that? And then I'll have 2 times cosine of psi, cosine of theta times cosine of psi. Here I'm going to have sine squared of theta plus sine squared of psi plus 2 times sine theta sine phi, right? Well, cosine squared of theta, sine squared of theta is 1. Cosine squared of phi, sine squared of phi is 1, right? So I have 2. And then I have 2 times cosine phi, cosine theta here. So I really have plus, if you look at this, it's going to be 2 times quantity cosine of psi, cosine of theta, and it's going to be plus sine of psi, sine of theta. You with me on this one? Now this is something you can look up if you don't know it. And if you have cosine A, all right, minus B, that's equal to cosine A, cosine B minus, or plus, I'm sorry, sine A, sine B. Y'all follow me on this one? I'm just showing you. This is how he did it. He didn't say it, but there's probably a trickier, more clever way. So when I come down here, all this A squared here becomes 2 plus 2, and it's going to be cosine of, and that's going to be, really doesn't matter which one goes first, does it? Cosine of psi minus phi, that's A squared. Y'all follow me? You're going to see it. I'm going to break this down and get it into something where it's just going to be a cosine of theta minus phi over 2 in a second. But y'all with me on this? Now, go ahead and, if that's A squared, this is actually equal to A. Do y'all agree with that? Now, do y'all remember this formula? It's the half angle. So do you remember that cosine squared of theta was equal to 1/2 plus 1/2 cosine of 2 theta, right? Y'all remember that? Isn't that right?
Yeah.
If you don't remember, you can always get these things, and I tell people this, I'll tell you probably a few more times before it's over. Anytime you wonder about this, you know that cosine of theta is equal to e to the j theta plus e to the minus j theta over 2, right? Go ahead and square it. You see you're going to get 1/4 out in front, right? Then you're going to get e to the j 2 theta here. You're going to get plus e to the minus j 2 theta here because they're both squared. Then you're going to get a product of this times this twice. Well, this times this is 1. So it's going to be plus 2, right? What is this? That's 2 times cosine of 2 theta. Do you all see this? Then divide by this and you end up with that. I'm just telling you that's what happens. Now look at this. We have 2 plus 2 times the cosine of this, right? So that's equal to 1. He made a mistake in the book here. So this is really going to be equal to 2 times 1 plus cosine of that, makes that a double angle, right? So it's, what it happens is that this is going to be, just look at this. If I take this right here, now really what I should do is I have 1 plus cosine of psi minus theta. Look at that, and look at this. So this is 1/2 right here, 1 plus cosine of 2 theta, right? That means 2 theta is equal to psi minus phi over here, if you look at that. Or really the phi integral that would be in the squared is going to be equal to that angle, psi minus theta divided by 2. And I'm replacing this with the cosine squared before cosine squared of that, and take the square root of that and it comes down to this. So this, and he'll have this, 2 times cosine of theta minus phi over 2. Does he have that, by the way, for A? Do you see it? Hmm?
Yeah, he does.
All right, now here's his mistake. A lot of time with a trig identity. He makes this whole argument equal to beta, but he forgets to take the 2. So now beta here he's going to make equal to psi minus phi over 2. He should have beta is psi minus phi. I think he does. Take a look at that, Zach, and just make sure. He'll have psi minus theta, or the equivalent symbols that he uses.
Yeah.
But he won't have the 2.
Yeah, you've read the 2.
All right, the 2 is important. All right. Now, come back to here. And I'm already out of time, but I just want to finish this thought. Now look here. You see how now I have really, you can say, you can make another variable, 2 beta equals another variable, but it won't matter that much to see what happens. But I want you to just see this. I'm going to say that beta prime is equal to 2 beta right here. Or I should say, 2 beta. So it's equal to psi minus, here, I'm using theta here. And I know I know what these functions, random variables are. They're density functions, right? So now what he wants is first he wants the value of A that solves it. And he has this for the value of A. And you all see how I got it. Now, there's probably a cleverer way to do this, but this is the way I did it because I know anytime I have problems with trig identities, I either go to using the fundamental definitions with exponentials for the trig functions or draw them up in 3D and just equate basically the horizontal and vertical components. That'll always work. Doesn't matter what the trig identity is, it always works. But here, now he says something about the probability of, what is the question? Probability, let me just finish this. Of
A being greater than 1.
A greater than 1. Now, I want you to think about this first of all. What does that really mean? Well, we could graph, if you take a look at A greater than 1, right? I didn't even write that down. That means A itself, I'm going to put it here. A was equal to 2 times cosine of, and I'm going to use beta, or I'm just going to use beta over 2, where beta is equal to minus 3. So if this right here, if A is greater than 1, correct? So that means 2 cosine of beta over 2 have to be greater than 1, right? Now, what does that really mean? Well, we have to take a look at what it amounts to. If we have beta, we need the probability density of beta. I mean, but really, what is this doing? We can say 1/2 is going to be greater than cosine of beta, right, over 2, correct? Well, if I just equated cosine of 1/2 is what? 60 degrees or pi over 3. Do you agree with that? So that means that beta over 2 would be greater than, or I should say, this is greater than 1 would be less than 1. And it would be magnitude of that greater than 1. And what I'm doing is, I know I'm out of time. If I take a look at a cosine function as such, because beta would be the argument, all right, and this would go, right, let's see, starts at 1, ends at 1 here. If we went from, say, from minus pi to pi, we could say that now the probability of, if I look at this, beta, the value of cosine greater than 1, if we limit our values of the function, the cosine function, instead of going from 0 to 2 pi, go from minus pi to pi, right in here is going to be the actual values over this span is where the actual cosine value is greater than 1/2. Because at minus 60 degrees, it's going to be 1/2. At positive 60 degrees, it's 1/2. This is not drawn very well, but you get basically that. That's what I'm saying. So what we need to do is find the density function for beta, and then integrate it and actually it's beta over 2, but it would be the equivalent of integrating this function, sine minus theta over 2, from here to here. I'm going to do that next time. I'm sorry I ran out of time on this one, but I want to at least give you a head start. I'm going to ask you to struggle through some of these problems. That's the trig identity for that one. The last two aren't hard. The next one after this is tricky. All right? But again, he doesn't just use y is z plus x. He uses y equals like 2y, or I mean, sorry, z is equal to 2y plus x, and he'll use z as like x minus y or something, where you have to actually restructure that integrated function. It's a pseudo convolution. Really, it's a correlation. I'm sorry I didn't get this done in time. But I went through this and I struggled with some of these things, messing around with those things. Usually I can, because I've done stuff like this before, I can fly through them fairly fast. But that trig identity irritated me. I'd like you to read the characteristic function, because once we get through these, you'll see the characteristic function. I'm going to do it in terms of Laplace transforms and Fourier transforms. It makes these things a lot easier.